In this video, I will show you how you can use the pipe network calculator. The pipe network consists of several interconnected pipes. The place where the pipes join is called a node. The method used by this calculator is the node method. For this video, I will use the simplest example of a pipe network consisting of only 3 pipes. All 3 pipes are connected at one point or one node. To set up a pipe network, it is always useful to draw the pipe network and label the pipes and nodes, as shown. Pipes are labeled 1 to 3, and a node is labeled 1. Points of the network with constant pressure at the beginning and end of the pipe are also nodes and are labeled 0. For our example, we therefore have 3 pipes, each with its dimensions in terms of pipe length, internal diameter, pipe surface roughness, and local resistance coefficient. The values for flow rate and fluid flow velocity are currently 0. After the calculation is completed, the calculated values will be displayed in those cells. Also, we have one node where all 3 pipes connect and its label is 1. For that node, it is necessary to enter the assumed pressure value in it, which in this example is 1.85 bar. After the calculation, the pressure value cell will display the calculated value in that node. The flow from that node outside the pipe network is equal to 0 and we will not change that value, for now. Now that all the values for the pipes and nodes are entered in the table, we can click the Calculate Network button and we will get the calculated values for the flow in each pipe, the fluid velocity in each pipe, and the pressure at the node in the adjacent table. As a check, we can see that the sum of the flow of pipes 1 and 2 is equal to the flow through pipe 3. In the table with pipes, we can also see the direction of fluid flow using the arrow pointing in the direction of flow for each pipe. Now that we have the complete pipe network set up and we can see the flow and pressure data, we can modify the values to analyze how one change affects other results. For example, we can change the inlet pressure for pipe 1 from 2.0 to 2.2 bar, by selecting the row where pipe 1 is, after which the values for that pipe will appear in the pipe input fields. In the constant pressure at 0 node field, we will enter a new value of 2.2 bar and then click on the Edit Pipe button. The new pressure value appears in the pipe table. Let's repeat the calculation and when we look at the results we see the new values. Now the flows in pipe 1 and pipe 2 are equalized, which is logical considering that the pipes are of the same dimensions and under the same inlet pressure. Now we can further correct our pipe network. We will change the length and diameter of pipe 2 so that the new length is 650 meters and the diameter is 125 millimeters. Select the second row in the table with pipes, which is pipe number 2, then enter a new value in the diameter and length input fields and finally click on the Edit Pipe button. Finally, we click the Calculate Network button and we have results for this new shape of the pipe network. Furthermore, we can assume that from node 1 we need to use 100 liters per minute. In that case, we select node 1 in the node table, and in the form above where the flow from node value is entered, we enter the value 100. After that, we click on the Edit Node button, and the new value is displayed in the node table. We click the Calculate Network button again and we have new solutions for the pipe network. We can confirm that now the flow through pipe 3 is 100 liters per minute less than the sum of the flow of pipe 1 and pipe 2. An online pipe flow calculator is available on the website pipeflowcalculations.com, as well as a short and detailed instruction. This example is only an introductory video, while for correct use it is necessary to study and apply the given instructions in detail. You can find the links to the pipe network calculator and instructions PDF file in the description.